So roughly what I want to present is my slightly meandering path towards on-demand documentation via code examples. So to set the stage, I'm really focusing on API tutorials. And when I or any programmer needs to find information about a new API they need to learn about, API tutorials are a common resource to get this information. Now, this is one example of a tutorial by Baldwin about the datetime API in Java. And one developer might start looking at it from top to bottom, reading everything there is to read. But that's not everyone. Some other developer might start from the title, jump straight to a code example, then the next one, go a little bit back to the section, forward again to a code example, and then realize, oh, I need to read section 2 actual. What I want to say here is that there are multiple developers who will read the same tutorial, so the same document, and will read it in many different orders. And the problem is that we have a single document that needs to address the needs, which are different from very many developers, and also the personality, their different patterns, their preferences. So there is a slight disconnect between the format of the tutorial, which is fixed. Once the tutorial is out, the author of the tutorial cannot adapt it to every reader, and the readers who have their own needs. My way to approach this problem is simply to say, how can we give some agency to the readers when they interact with the documents? So instead of having a fixed monolithic static document, can we make it a bit more accessible, give some decisions to the readers so that they can adapt it to themselves? I went through this process in 3 main projects. So the first one, it was code. The goal of this project was to list the concepts that the reader needs to know about before getting into the document. Then I studied some tutorials to understand a little bit what is this design space. So basically, what are the possibilities to design different documents for each reader? And this led me to designing Casdoc, which is a new format for documentation, which is a bit more accessible, a bit more adaptable, more personalizable to the readers. So let me go through them. First thing first with code. So I said it's an approach to identify what are the concepts related to a specific project. I'm talking about a specific project, so think about an API, but it could be an end user software as well. I make this link here for this project between the project and its documentation. If the documentation relates to some concepts, then I assume that the project will relate to those concepts and vice versa. So to introduce code, let me show you this excerpt, which is the first document that you'll find if you read about the Signal Messenger application. Signal is a privacy-conscious messenger application. And this is the very first document you'll find. And this is the introduction. This document describes how to create and verify DSA compatible signatures using public key, private key, for the X25519, etc. Now, you're all smart people, so I don't know that you immediately know what are DSA and you're intimately familiar with elliptic curve diffie-Hellman function. I wasn't when I started reading it. So it would be nice to at least be able to understand, okay, before jumping into this very technical documentation, what do I need to know to be able to even understand what this document is telling me? And it would be nice to know it before even getting in the document so that I can read up, fill any gap in my knowledge that I have, and then avoid context switching between multiple documents. So this is exactly what we did. Each concept needs to be identified by a Wikipedia article, which is simply a way to standardize a list of concepts. And then there are these very cool tools called Wikifires that automatically take any natural language text. Obviously, we fed them English text and can return links to Wikipedia articles. So awesome, problem solved. With this text, for example, which is, again, a real example, it can identify that the mention of a trigger relates to a database trigger as opposed to other triggers in normal life. But you probably see me coming with any automated approach, especially information retrieval approaches, there are false positives. Now, this is an exercise for the audience. There is this small text about Maven dependencies. And again, this is all real examples. A Wikipedia decided that this was related to the Burmese language. And this is in this text. So anyone who wants to venture a guess as to how the Wikipedia made the connection between Maven and Burmese? Yes. Sorry? No. Well, I appreciate the try. Anyone else? So I didn't notice. I had to look pretty deep for it, but it happens that the two-letter code for Burmese is MY, which just happens to be a very common English word. Two-letter code, just like in English, it's EN, Italian IT, right? So there are obviously false positives. Are there really a problem? Burmese was one of them. But to identify how well Wikifires, which are developed for natural language general purpose text, work with software documents, we decided to take 500 Stack Overflow posts, feed them to Wikifires, get all of the results. This created over 40,000 pairs of posts and Wikipedia articles, and painstakingly annotated each of them as either being correct or incorrect. This was long, but led to some fun associations, and ultimately to this very nice graphic, which shows us the performance of each Wikifier. So on the y-axis, you have the precision, which is roughly, well, not roughly, exactly the ratio of all the results of one Wikifier, how many of them are correct. And on the x-axis, it's the recall. So from all the possible concepts that are related to the post, how many of them does the Wikifier identifies? So ideally, you want all of them to be 100%, find all the related concepts and only the related concepts. And for each Wikifier, we have a line which identifies, which stems from the fact that each Wikifier has a confidence parameter. So you can tune whether you want the Wikifier to be more conservative or a bit more relaxed, but ideally get more relevant results. This is the one series for one of the Wikifier DPpedia, and you find that it's not doing so well, right? It gets close to 100% precision, but for very little recall, and as soon as you get a bit more relevant concepts, the precision drops very quickly. If I show you all the Wikifiers, well, they're all of them not actually so great. This is not to dump on the Wikifiers. They do great work, and it's a fairly mature field in computational linguistics. But it so happens that Wikifying software documents in particular is hard. So yeah, again, we get very little recall and precision. None of them get over 50% precision for even 20% recall. Concretely, that means that if you want to get one out of every 5 concepts related to a post, you get more false results than true results. And another interesting aspect is that even though this field has been going around for some time, there's no clearly superior option. So if I'm to use a Wikifier for a specific application, other than just evaluating them, it's unclear which confidence parameter I need to use, how to tune them, and also which one to use, because they kind of go all over the place. So we found some way to improve the precision simply by filtering the results. We found some heuristics, but the true challenge is also to improve the recall, which is lacking. How can you identify the missing concepts if you have nothing to go about? And for this, we went on back to Wikipedia. So again, all of the concepts are Wikipedia articles, and we can use Wikipedia as a graph. Each node in the graph represents one article, and the links, the wiki links between articles, are the links in the graph. In the network science, there are these very nice algorithms called community search algorithms, where you feed them a network and one target node, and they identify this group of densely connected nodes containing your initial query that represents a topic, well, in our case, a topic of concepts all related to each other and ideally related to the original software project. Now, again, we went around. There are a few of those community algorithms, community search algorithms, sorry, that have different properties depending on if you want larger communities or more narrow communities, depending on how you even define a community. I will go through all the details, ask me later if you want. But essentially, we mix and matches a few of those algorithms to identify nice communities for our purpose. And then we went a bit beyond because we don't want to show too many concepts at once. So for each topic, we also identify one representative concept, which might be different than the original seed concept. So all in all, what we do is from the wikifires, feed them to the community search algorithms, get the communities through a mixture of different algorithms that involve some merging. So two concepts might merge into the same topic, which to me makes sense. And then ultimately find a representative for that topic and present this as the result of Scope. So we use this approach to implement a small demo application, which simply takes a software project, takes all of its API documentation, reference documentation, gives them to wikifires, and use the output of Code to identify the set of topics related to this project. And we can put them as badges under README, for example, of a GitHub project, so that any user, developer can look at it, see if they are already familiar with all the topics, and if they are not familiar with one of them, for example, relational databases, they can expand on this topic and look at the different concepts related to it. And all of this is linked to Wikipedia, which again is a nice way to give them some seed resources to start learning more about the topic. So ultimately, this is also that programmers can identify before even looking at a document whether they have gaps in their knowledge, and if they have some, well, address those gaps or maybe find different documents, or in this case, different projects. Now moving on to the next project, let's say I do know that I have the prerequisite knowledge for some document. I still want to learn about some API. So going back to our scope of API tutorials, we wanted to understand what is this design space? How do tutorial creators change their documents, change the format or the content to tailor some tutorial for a specific audience? To this, we wanted to focus on high quality tutorials. So we only took tutorials from reputable organizations. We looked at 3 tutorials, one from Android, the Android Foundation, one from Google, and one for Vogela. To further restrict our scope, narrow our scope, we only focused on Android tutorials, as you can see, and Android tutorials for novices. Not necessarily the first programming tutorials that they will learn, but for an audience that haven't had any Android programming experience before getting to this tutorial. So we have a fairly restricted but focused set of 3 tutorials that we compared to each other to try to understand how does their design vary. This will be on the test later. So this was a small project with another PhD student, Diksha Arya. And remember, her name, she'll come back later. So as I said, we compared all 3 tutorials. We focused on a quantitative comparison of both the content and the organization. For the content, we use Stack Overflow tags. All of those obviously related to Android, as the standardized set of topics. For each tag, here ordered by popularity, we identify whether each of the 3 tutorials cover the topic or not. This was a binary classification, so a deep red if the topic is covered. For example, all 3 tutorials cover which IDE to use with, well, in this case, Android Studio. But you can see that the Android tutorial on the right doesn't cover fragments. We use a binary classification just to simplify the analysis later, but this gave us this nice visualization of a matrix to see at a glance which topics are covered or not. And because they're ordered by popularity, we can see where the trends are. In terms of organizations, we looked at different structural properties. I have 4 of them, but we looked at even more, the length and number of code examples and sections. So for example, above, you can see that the length of code examples, in this case, the number of characters per code example, is fairly larger for Vogella than for the other 2 tutorials. So this gives us some insight about how tutorial creators decide to make tutorials. Do they prefer a lot of small code fragments, or in the case of Vogella, larger but fewer code examples? Now I won't go through all the details, but just to show you some idea of what we found. I'm going back to this matrix of coverage. I'll rotate it and then show you the whole matrix for all 400 Android-related tags. And as you can see, it's not super easy. So if you can make sense of it, that's awesome. We spent some time and we ultimately did identify different patterns, but the main result is that it's really hard to even make sense of which tutorial will cover which topic. And this is a problem, right? If I'm a user, I want to learn about a few different topics that I know in advance. It's hard to know which one, if any, will cover that topic. And for different users with different information needs, this problem is even more complex. So this is one example, but it is the main result across all different patterns. The tutorials vary in their design, but it's unclear whether this variation is intentional and what are the implications on specific audiences. So moving back to my last project, I wanted to have a deep dive into one aspect of a tutorial format. And so what I did was to create my own, which we call Casdoc. So Casdoc is a format for code-focused tutorials. The format starts with just one code example, or at least focuses on one larger code example. But different users might have questions about different part of the code example. So you can see different parts of the code here being underlined or highlighted on the right. This means that there is further explanation about what this does. If you don't know why someone might use UTF-8 in this method, then you can hover over it and reveal additional explanation. But someone else might already know this, but instead worry or ask about why we convert a message to an array of bytes, in this example about cryptography. So the point of Casdoc is to focus on a code example and then allow each developer to really get further information based on what they actually need, rather than presenting them with a large block of text that they need to jump around. One very important aspect of Casdoc was to create a format that is useful for readers, but also not extremely hard to create for writers. So we implemented this process where to create a Casdoc document, the writer will simply start with a working Java file, which allows them to test them, use in any version control system, all the tools of good development, and add all of those annotations as comment in the code using a lightweight DSL, domain-specific language. And then we have a transformer that will take all of those comments and move them into annotations to create the working dynamic HTML file. So this was a nice project where we wanted to obviously evaluate it and also use it to understand, to study how readers, how programmers access information in documents. So we conducted 2 studies. The first one, a lab study, was in a controlled environment, so with fewer people. Each participant would complete some programming task over 40 minutes. And with them, I was there during their session. I would ask them to say aloud their thought, ask them to clarify if I can hear, that kind of stuff. And at the end of the session, have a short interview questionnaire to get additional feedback about what they found useful or not useful with the curated documents. The other study was a field study. So this was really gratifying. We created over 100 documents in a Casdoc format and made them available to over 300 students in 2 undergraduate courses at our university. The students use the documents as part of their course material over the whole course, so 2 sections of 3 months, 3.5 months each. And we automatically collected all their interaction with the documents through the terms as they use them. So the lab study, the first study, really gave us deep insight into when participants use specific features and how they use them to get access to information. And the field study gave us a lot of data points about what features are used more often, how they use features together or not. I'll again go over the details quickly, but definitely feel free to ask me more or well, read more when this paper will be published. Yeah, second one is getting published, this one in the works. Sorry, but yeah, for the lab study, as a glimpse of the results, we asked them at the end, how easy was it to find information that they wanted to find in both Casdoc documents and the baseline documents, so simply a static format of the documents. Most of them found it easier. So on a scale from extremely hard to extremely easy, most of them found it easier to find information in Casdoc documents, but there are a few notable exceptions. But beyond that, we also found that there were clear patterns that integrated both Casdoc and the baseline. One of them, described by P3, but that was recurrent across many participants, was that they would first look at the code, then the code annotations, and then if they didn't find it, to the paragraph. So they didn't exhaust any of the format before moving to the next one. And another very interesting pattern that we did not expect is that many of the participants said or showed that they trusted the static format, so the baseline, the more traditional format. They trusted that it held more information or more reliable information than the annotations. So beyond how to present the information, there is this possibly cognitive bias into where the information should come from, in a way. Ultimately, we found that Casdoc is easy to navigate, but specifically easy for factual and short queries, something that requires more time, more information would simply take longer. For the field study, as I said, we give our documents in both versions, Casdoc and a baseline, to over 100 participants, well, over 300, over 100 accepted to participate. Most of them, this was really encouraging, only use Casdoc through the terms. A few of them tried both formats, and only a minority, 5 of over 150, ended up using the baseline format through the course. So this is encouraging result that Casdoc is a viable format for programmer information. And going deeper into the results, most of the participants, 70%, use annotations. So they didn't just look at the code example. But something interesting, they only use annotations on a fraction of the documents, so about 1 in 6 documents. So for most documents, they didn't feel the need to use annotations. And yet, despite all of this, all participants together had at the end of the term looked at over 60% of the annotations. So it's not like most of the annotation were effort wasted on our part. So ultimately, we found that Casdoc is useful for annotations, but readers use them only sparingly. So all of this together, I hope, gives you a sight of not only my PhD, but also how I went from one project to another, I definitely feel like it wasn't straightforward. I know the start, where I want to end up, and this is where I reached at the end of my PhD, but I'm actually really appreciative of my path through different projects and different research methods as domains of inquiry from HCI to network science to ultimately arrive at Casdoc, which is a useful prototype or useful tool for documentation. Taking a bit forward, where to go next? One obvious answer would be to merge Casdoc and Scode. So it would be nice to be able to automatically generate some of those annotations based on Wikipedia using the concepts that Scode finds. I'm also interested into the cognitive aspect. So I started a presentation presenting 2 ways to navigate some tutorial documentation. Can we infer which way one person will use based on cognitive aspects like psychometric tests? Also want to mention the authoring process. So this is something that I didn't spend too much time looking into, how much effort goes into creating tutorials and in particular documentation, but Diksha is working on this. So going from our joint project on the tutorials, she continued towards what are the motivations, the different factors that help tutorial writers create tutorials, and also what are different styles of tutorials that they can create, and then how can users adapt those styles, specific parameters of those styles to suit their needs. So this is some very interesting work that I wanted to mention, also because Diksha is running a survey, and I know Marco already published it, but if you can help her get to the end of her PhD, give her a little bit of your time and participate in her survey, she'll be immensely grateful. And finally, the next step, which is currently happening, which is to make Casdoc really a viable product in the world. So we continue to improve Casdoc. We continue to change the design based on the results of our studies. And it is now, we now have a set of Casdoc documents on the public website, codesample.info, that you can have a look at. You can also create your own Casdoc documents if you're interested and get in touch with us to get the last version. The web service online is a few versions back. But this is really something that my old supervisor and I want to push forward. We want to have an impact not just on research, but on the community. So with that, I'll conclude my talk. Once again, I'm Mathieu Nassif. I don't know exactly where I'll be in a few years, but you can still reach me either at this email, which is permanent, or on my website. Thank you very much.